Today I'm going to explain to you why US school districts use caching to help manage growing demand for online learning in a more sustainable and affordable way. So the company is called ApplianSys, and for the last 20 years we've been working with schools and education content providers like Pearson and specialising in a niche area of the caching market, which is caching for education. With our expertise in this field, we've developed the only schools-focused caching solution that's designed to handle the entirety of schools' web traffic. And since US school districts are using more and more online learning every day, it's no surprise that we are the most widely selected caching solution in the E-Rate programme since 2015. So what I'm going to talk about today, we're going to start by looking at some of the unique challenges that modern schools face, and how web caching provides a great response to these. We're then going to move on to take a look at how this growing demand for bandwidth, it never stops. So you buy more bandwidth and the next thing you know, you congest it again. So what we're going to do is we're going to show you how you can slow down that reactive cycle of constantly upgrading bandwidth by managing your demand more efficiently. And finally, we will consider exactly what schools need to think about when they're considering different caching solutions. So first up, I'm just going to talk you through how caching works. Now, what happens is a user makes a request for a page or an object from the internet, and the cache box sits in between the user and the internet and intercepts that request. It saves a copy of the object, at the same time serving it to the user. Now what this means is the next person who makes a request for the same page or object, they're going to receive it from cache, which means it's served locally and you don't use your internet connection to fetch it. Now the cache box is clever because it makes sure that content served to users is always up to date. The way it does this is once it identifies that a requested object is in the cache memory, it sends a tiny file to the internet to double check if any changes have been made since it was stored. The cache box then downloads only the new objects and replaces these in the cache memory. That means that you are serving content faster, using your bandwidth more efficiently, and ensuring that cache content is always up to date. So let's take a look at some of the challenges that modern school networks are facing. Well, in around 2012, K-12 saw a dramatic increase in classroom devices, and this went hand in hand with a huge burst in demand for bandwidth. We've also seen another acceleration in this more recently in response to the COVID pandemic. Now, it's clear that e-learning and interactive resources have a proven impact on learning outcomes, and they're becoming increasingly prominent in the classroom. But what that means is that learning outcomes are now innately tied to internet performance. So it's up to tech teams to ensure that students and teachers can access fast and reliable internet at all times, despite the fact that demand is constantly growing. And this burst in demand explains some of the challenges that schools and tech teams are experiencing today. For example, teachers and students want to use more video content, but video files are huge and put a large strain on the network. What that causes is slowdowns in the classroom, videos buffering, complaints from students and teachers, and ultimately lessons are disrupted. Now all this goes to show that you're not going to get the full benefits of using video in the classroom or having a one-to-one scheme if you aren't managing your bandwidth as effectively as possible. And when these growth challenges come in, what you tend to see is they happen in phases. So first of all, you introduce a one-to-one scheme and maybe you roll out a batch of devices and you see a big spike in demand for bandwidth. But the reality is even if you don't add any more devices for the next 3 years, you are still going to see demand continue to grow because teachers become more fluent, students use more online content, and objects on the internet are getting bigger all the time. And so what we're seeing is, over the last 10 years or so, demand has grown at an exponential rate, but tech teams generally haven't, at least nowhere near at the same rate, which is an obvious limitation. So now we're going to have a look at the bandwidth side of things. Now, caching makes a lot of sense when you look at a school's web traffic profile. We have reporting that give you great visibility over web traffic. And just to show you how different and unique a school environment is, I'm going to show you the difference between an ISP environment and a school's traffic profile. So here we have an internet service provider serving residential and business customers. And this is a graph of their web traffic on an average day. So what you tend to see is around kind of 8, 9 a.m. everyone wakes up, they go to work, and we see this spike in demand. And then it kind of steadily peters off throughout the day until late in the evening when everybody goes to sleep. Compared with a school environment, this is very different. School's traffic is much spikier. You see this huge difference between the peaks and the troughs. And that happens because teachers tell students to access the same content at the same time. And when lots of people are simultaneously trying to access the same content, the same video, the same software update, that's when you see these huge peaks in demand. So when you add into the mix that students all trying to access the internet at the same time, what they're doing is they're often trying to access the same content. So these spikes are actually often made up of repeat requests for the same video or the same software update file, which means that these peaks lend themselves very well to caching. Now, if you want to deliver quality internet in the classroom, you need to meet these peaks in demand. But these peaks only happen for a very small portion of the day, maybe 10, 15%. And all of this grey indicates the amount of time that you're paying for a bandwidth connection that you are not using. So if you reactively upgrade your bandwidth connection to accommodate that 10% of peak time demand, it's really not a good return on investment. However, if you can slash these peaks, that's where you're going to see the best savings. And that's how you can slow down a reactive cycle of wastefully upgrading your bandwidth connection. Now, I mentioned earlier you get great visibility from our reports, and you can see how much traffic is passing through the box from different domains. You can see how much bandwidth you're saving in the percentage cached. And you can also see data on how much faster it's reaching users because you're serving it from the local area network, which I'll go into a bit later. And in this data set, what you can see is the percentage of content that is being served from cache and the total transfer from different domains. So as you can see, schools are able to save gigabytes and terabytes of information. This is another graph that kind of demonstrates the additional virtual capacity you get from CacheBox. So in the light green here, the ETH transmit max, we see the amount of content that is being served from CacheBox. And in pink, the receive max. This is what's left to come from the internet after the CacheBox has done its job. So rather than going out to the internet to fetch these huge spikes in repeat content, you're allowing your internet average demand to stay lower and fetching the peaks from cache. We call that additional virtual capacity, and it basically shows how you can extend the life of your bandwidth and stay at your existing connection for longer. And why do you want to stay at your existing connection for longer? Well, there's a lot of hidden costs to upgrading bandwidth. So once you go beyond various thresholds, 100 meg, 1 gig, you often have to upgrade a lot of your network equipment. Now, if you can delay planned bandwidth increments and get another year or two's life out of your current connection, you can save on your monthly costs across all of your network equipment. So moving on from the bandwidth side of things, the other side of things is acceleration. So I'm sure you've heard teachers reporting internet speeds are not fast enough, they're experiencing buffering. And what usually happens is when you first upgrade your bandwidth connection, speeds are much faster. Everybody uses the internet more because it's going so well. And yet the more people use it, the more demand increases. And within 6 months, you're already seeing problems with congestion and slowdowns. Now this report here is taken from one of our schools using Cashbox. And what you can see is the difference in serving content from LAN speeds, which is the cache hit, and the difference in content fetched from the internet. So that's the cache miss. Now the cache miss, you can see nothing's really coming in any faster than this 10 megabytes per second threshold. And you've got a large cluster of requests closer to the 1 megabytes mark. Whereas when you're serving content locally from cache, you're speeding it up by 5-10 times faster. And this cluster of demand has all been accelerated way above the peak threshold. So a lot of people do use Cashbox for bandwidth management reasons, but the speed increases are a huge benefit to many schools. In terms of how that looks in the classroom, you can see how much faster some of this content is being served in our data shared from Anaheim Union. Now you can see here Apex learning content is reaching students nearly 50 times faster, which makes a huge difference when it comes to the online testing season here. And in general, popular education content is being served faster, which has a massive impact on the experience in the classroom. This is where teachers and students see the biggest difference, when you can serve content 10, 20, 30 times faster. In addition to this, with, for example, software updates, serving these from cache are also served significantly faster, which means you clear them from your internet pipe quicker, avoid congestion, and make way for other popular internet requests. Here's another example from East Peoria. Here you can see junior achievement content is reaching students over 200 times faster, making a huge difference. Now, for example, video content from the district's own domain and state resources, k12.il.us, was actually buffering at about 230 kilobits per second, but with Cashbox, they're offloading that demand and they're able to serve content 14 times faster. So, in summary, modern school networks are facing challenges with growing demand for online learning and these huge spikes in bandwidth consumption. This happens when students try to access the same content at the same time. And the reality is that reactively upgrading your bandwidth is not an efficient way of dealing with that. Building caching into your bandwidth management strategy, however, it allows you to get more out of your internet connection while serving that content much faster to students and teachers. And when we've looked at exactly what schools need to consider when they're evaluating caching solutions that are going to offer them the best value, I mean, first up, you need to cache as much content as possible. We are the education specialists of caching and handle all different types of schools' traffic, including HTTPS and video content. That is something that is not easy to do and we uniquely offer in the caching market. We've also built in features like the Cashbox Media Library, where teachers can log in, store online content like YouTube videos, for example, and share the URL with students as and when needed. This means you don't put any demand on the network, you don't need to request anything from the internet, but teachers get complete control over how students are accessing YouTube. There's no ads, no inappropriate comments, and no buffering. And finally, our user interface and reporting offer you outstanding visibility with performance analytics on bandwidth consumption, savings, and speed increases. So you know exactly what users are doing and how effectively you're managing your connectivity. And now I'd like to introduce Chris Rule, one of our customers from Sublette County, and he's going to tell you a little bit more about his experience with Cashbox.
ApplianSys, a company out of the UK, has developed this Cashbox, is what they call it. And they come in different sizes, and it does exactly that. It sits on your network, it monitors your traffic, you configure a number of different things, and it caches the content. And not only does it do it transparently and on the fly, but you can have predefined libraries, your most common things, Windows updates, Adobe updates, Apple updates. There's, I think, 19 different packages. I'll get on to show you the interface. But I think there are 19 pre-built packages that it automatically looks for that content and delivers it. So on our network, instead of having a Windows update server, which I've had in the past, and it's yet another thing to have to manage, and it's a Microsoft product, and so it's weird to manage and it fails all the time. This just transparently sits there and monitors your internet traffic. And when I go out and get the pre-build for Windows 11, and it automatically updates that, and when Gavin goes to get it, he downloads it at network speed. And so we'll see our updates. They'll come up and say you have downloads, starting download, finished installing. Where it used to be, you have downloads, 1%, 2%. It was like the install was faster than the download. Now that's not the case because we're delivering that at network speed. Plus, the real advantage is that now that bandwidth is freed up for the real things that we need it for, right? I don't want to be consuming that during the day when we're potentially needing to deliver video to a classroom, especially if we have remote learning kids that that's not something you can cache. You can't cache live video, right? But the other things that are happening around behind the scenes that happen at the same time, we can cache those and offload that so that it's not consuming, not taking all of our water pressure from our plumbing, so to speak. So I would like to share my screen, see if I can do this. So I'm already logged into our Cashbox, and the default dashboard just kind of shows some quick information. It immediately shows me what my top domains are. Microsoft.com is my biggest one right now. Windows Update, is the second biggest one here. This is just kind of quick snapshot information to take a look at. Where I generally go is I go and I look at cache. Let me see if this will actually, my touch may not work without this on here. It might be a Zoom thing. It might be a Zoom and a remote thing all in one here. So this is a quick screen. It's kind of a diagnostic screen that just is going to show you what potentially is being caught. So everything that is in the column right here under hit that is a green, that's something that is a positive. It's the Cashbox sees that and it's delivering it at network speed. But the one thing I'd like to point out, and it's not super clear, but right up here under statistics, this first line says byte hit ratio 5/60 minutes. What this says is in the last 5 minutes, 87.9% of my traffic was cached. It was delivered by the box and not through the internet. And over the last 60 minutes, it's 39.5, almost 40%. This particular box has like 3.5 terabytes of storage. Some of it is flash. It's like solid state hard drive, and some of it is just strict memory, because the objects that need to be delivered the fastest are in memory, and then the larger objects like updates and things that don't need to be delivered like instantly, those are stored on solid state drives. So it's still fast delivery, but it's not as fast as in memory. If we go to content, actually, I'm going to show you reports before I talk about the libraries. So reports, looks similar to what that first screen did. I'm going to go to, let's do a highlight report. I can choose my reporting based on days, based on week numbers, and based on months. So let's just take a look at September of 2021 and get this report. So this will show us kind of how my box performed and what it potentially saved me in the month of September. So it says my bandwidth total was 962 gig, and the bandwidth saved was 732 gig, which is a 76% savings on the total bandwidth that came in and out of my district. So I don't know if ETS appreciates that, but that's bandwidth that if I'm not consuming in another school, potentially could be, right? Because it all goes back to kind of one source. That's huge right there. I can scroll down through here and it'll tell me what the largest byte hit ratio. PowerSchool was really big, Edge Elastic, Common Lit, ReadWorks, Code, probably code.org. Tells me the application acceleration for different things, Teach TCI, Typing Agent, PowerSchool again. Just kind of geeky numbers, right? You can go in there and look and go, wow, that's, even though our PowerSchool still is hosted on site, and even though it's still on site, it's still running through the cache box, because cache proxying initially was actually built for the providers. So some of this is, some of these numbers, I couldn't tell you what some of this stuff means. A lot of it is more technical. I can just show you that it saved us a ton of bandwidth. Let's look at the content. So they call it a CDN, and I don't know what that stands for, but these are the libraries, and I have 93 enabled right now. And the ones, I'll just show you the top ones that are built in here: 4Share, 9 apps, Adobe, Amazon, Apple, Avast, Blizzard, CNN, Dailymotion, Disney Plus. There's a whole bunch of them in here that are pre-built, and these are ones that they knew were high bandwidth items, right? The company did. You could go and build this yourself, but to do it and to keep up on this would be tough. I just wanted a quick appliance that I could throw in. The support from these guys has been great. The support's out of the UK, so it's fun to talk to them. It's not like I have to call them in the middle of the night, right? They work on our time frame, but they've been awesome to work with. We've had very few issues, and any issues we did have, the team was right there with us. Gavin and his team helped a couple times on our initial deployment. We just had like some quirks that needed to be worked out, and he put us in contact with those people. So we're on our second box. We had our first box we bought and had it for 5 years, and this is our second box, and this is the second year we've had for it. And essentially we bought a 5-year kind of rotation protection upgrade cycle. I can't remember what the initial cost was, but I think this last box that we had that was all refresh was like around $5,000, I think, for the box that we have. And yeah, we don't pay for the bandwidth in our state. Other states do. We don't. But to me, the value of delivering that information just so quickly, and then having that bandwidth available for other districts, even though we weren't out of bandwidth, right? It's still, the network is so much more responsive and snappy. You're not waiting for things to load. It's a really good product. I just think that I'm just passionate about every district needs to have some sort of caching solution.
If you like more information about Cashbox, you can visit our dedicated US schools website, or alternatively, you can book a session with one of our consultants. Thanks for listening.